Hello, front friends. Hello, Poland. I am so excited to be here. This is my first time in Poland and also a first conference talk. But continental Europe is not new to me. I have been traveling here for a lot of time. In fact, 4 years ago, I traveled here for 3 months in Scandinavia, in Balkan, in France. And I went back home and I told myself, that's it. I know what I want to be. I became a web developer. So that was my 4 years of journey of web developer. But today, I also want to talk about how web development merges with my first love for technology. And that started almost a decade ago. As a young student in electrical engineering, this was one of my projects with a team member. And we built a boat. And this is the internals of the boat, as you can see. Pretty complicated, right? Let me show you a video. This was an amphibious vehicle. As you can see, it rode down the ramp and made a little turn. It was with a tiny microcontroller, PIC 16, with a tiny amount of flash and a RAM. Now, although I understood what technology and engineering could do, I did not really get the fast feedback about building with engineering until I discovered web technology. Guess what? With web technology, we take out our text editor, we do something, and take out our browser, and voila, there you have it. Instant connection, instant gratification for an inventor. But I'm so happy that my world of electronics and web development is coming to merge, especially in terms of immediate connection. And last year, I got to observe Node Boats, which is a day-long workshop. And from there, this is what the participants built. Just within a day, you didn't need electronics background. You probably even didn't need much web development. And this is what I want to talk about. Now, not to say that whatever I learned in engineering for 3 months was thrown away. Sometimes you do need some time to learn JavaScript before learning AngularJS, or learn CSS before learning some preprocessors. But when we combine our fundamental learning with fast feedback, this is what I call the inventor's delight. And I'm so happy that in the current few years, we can kind of merge these two. Is electronics easier in today's world? Well, something in engineering on technology, if it becomes easier, it's because something is happening underlying in the abstraction layer. So I wanted to take you through some of the abstraction layers right from the world of physics, governed by the laws of maths and science, and go up right at the top to the apps layer. So in the physics layer, what is happening? Sensors like these are becoming much, much cheaper, which means whether you are an electronics engineer and you want to prototype something, or even beginners like among us can find it easy to just acquire them. In terms of hardware platform, which is built on top of the physics layer, we are also having a lot of functionality built into these tiny little PCBs. You have like ports being added to it. You have microchips. You have Wi-Fi chips, all added right here. Then you have the operating system. All of us carry mobile phone. We have embedded Linux. Now, my first programming language that I learned was C. But I'm so happy that we are having more and more language support coming for hardware as well. And then in terms of framework, we are also having browser API support and JavaScript libraries, which I will touch on. And so what next? At the app layer, we are ready to build it ourselves. Now, let me touch a little bit about the network protocol, okay? So web is not the same as internet, okay? So in terms of, once again, the IP or the Internet Protocol network layers, we have the physical layer. And I'm very, very excited that in the current few years, we also have things like some low-power wireless protocols, such as the Bluetooth Low Energy. In terms of the Internet layer, we also have things like IPv6 or 6LoWPAN that can allow a lot of tiny devices to be connected. And then, of course, the web layer that all of us are familiar with. With WebSockets, WebRTC, and more, we can build a lot of cool stuff. Great. So in this talk, I'm going to talk about how we can connect to the real world in terms of sensors in just 3 demos, okay? And each of the 3 demo, I'll go through the code, a little bit of demo, and also some other libraries that you can take home and then work on them. All right, great. So let's start with phones. And for that, I need all of your help. Take out your phones, okay? And you can go to this website. You can either use the QR code and go and scan it, or you can just type it out. Remember, it's HTTPS. All right, and let's connect to it. Let's see who is the first one to connect. All right, so you will probably have a username, and let's see if it doesn't work. Ah, there you go, Kamil, Igor, thank you, thank you. Thank you. So what you do, take your mobile phone and answer this question. Have you played with WebSockets? So you can put it down if it's no, and you can put it up if it is yes. All right? And as you are using your phone, you will see the angles change. Everybody is no? Somebody green? All right, there you go, Kamil, and after design is green. So you can hold it up if it is yes. So you actually have 18% exactly for among of you who have voted that you're saying that you have played with WebSockets. All right, so let's go on to the next question. Do you know that there are many sensors in the phone? So if you're still trying to connect, you can go to HTTPS and then poll.Sayanee. So how many of you know that there are many sensors? So you can once again just tilt your phone, yes or no. So yes, like this, and no if you're down. Okay? But either way, as you're tilting the phone, you should be seeing the angles being changed, right? You'll see the numbers there. That is like the front, back angle, and you can also tilt it left and right to see the changes there. Great, and maybe the last question. Are you having fun with device orientation API? Okay. All right, so I will go on to the code probably, and then explain what exactly am I doing. So what I did here is I actually accessed the device orientation API right in the browser. And in this case, the hardware that I'm using is just your mobile phone. And then I also used WebSockets on the client side and the server side, which, by the way, I hosted in Heroku using IO.js, and they are just talking to one another. So using all your angles, I'm just grabbing it in my server, and I'm displaying it. All right, so let's go through the code here. So even today, if you just go to your index.html or JavaScript, if you do window.add event listener, and then for the first argument, if you do device orientation, you'll get back 3 values from your mobile phone. The first one is alpha, then the beta. Beta is the one that I grabbed from all your mobile phone. It is basically the tilt from front to back. And then gamma is the left to right. And of course, I also use socket IO, and then I kind of send it to the server. So I said that, okay, so if it is below 15 degrees, then send a no, and above 75 degrees, send a yes. So you can get my full code over here later on. So one of the challenges of working with sensors is this. The sensor data tend to be very jittery. So one advice I can give is use a smoothing algorithm or a low-pass filter. Also, it tends to be very raw. As you can tilt your phone, you will notice that the numbers change very fast. So you might need to sanitize it or change the 0 point, or even add a multiplier to make it bigger or smaller. It also tends to have a high precision, so maybe you can round up and round down. And also, you will need to calibrate it according to the environment. I remember once using light-dependent resistors in a workshop, and then when I came home, it wasn't working. Well, guess what? I had to calibrate it according to my home lighting. Awesome. So I also have 2 other libraries to recommend to you. The first one actually does a normalization of the full tilt. And the second one is a pretty cool, fun library to work with device orientation. It's called Parallax. So go and try it out. Now, this world of linking the sensors in the phone to the browser is very new, and a lot of things are still being worked upon. So keep in view this device API working group by W3C. And here you will see things like proximity events, event light, ambient light, or even if you scroll down more, there is temperature, humidity, pressure. They are all being currently worked upon or delayed. But more importantly, if you're interested, get involved as well. So this is all found in the W3C. In the future, there will be more sensors coming from your phone supported natively in the browser. And if today you want to play with sensors in your phone, by the way, there are tons of sensors in this tiny little device that we carry in our pocket. Check out Sensortag if you're an Android user. You can just download these app, and then from a browser, you can access the sensors in your phone. I didn't even know that other than accelerometer, there was even light and rotational vector, pressure, orientation, and so much more. If you are a Firefox fan, you can also turn the entire PCB, the phone, into an IoT or an Internet of Things board with Yarn OS. Awesome. So let's go to the next one, which is over HTTP. And I think as web developers, we are all very familiar with this. I want to talk a little bit about some of the boards I have here. So here I have Arduino Yun, as you can see. Right, so a lot of us might be familiar with Arduino, right? So Yun actually combines Arduino as well as it comes with a Wi-Fi chip on board, like I wrote there. And it also has the amount of I/O pins, which some of them can be digital or analog. And the firmware code you write here is basically Arduino. So let me talk a little bit about what is a digital pin and an analog pin. So digital pin, you can set it using just high and low. So there's just two values, binary. This can be used to turn on and off an LED. The other pin is analog. So if you have a range of values, so for example, later on we will use CSS colors, which is from 0 to 255. This is where you use the analog pins. Let me give you the next example, which is basically the Spark Core example here. All right, so there you go. That is the Spark Core example. Now, I have all these devices, so if you want to see it up close, come and talk to me. So this is a tiny little Spark Core. It has a Wi-Fi chip on board. You can program it. And the cool thing is you don't have to set up the server, everything. So Spark comes with a Spark Cloud. So from the tiny device, you communicate with the Spark Cloud, and then it comes back to your server. And it also comes with its own I/O pins. It has digital pin, analog pin, PWM, and you can also code it in Arduino or C. All right, so we're going to have a little demo with this. So what I wired up here is firstly the RGB. So what we're going to do from the browser, we are going to try to change the color of the LED, okay? And all we are doing is sending HTTP post request. I think as web developers, we are very familiar with this concept. And all we are doing is kind of setting, hey, this is the pin we want, and let's set it to a certain value. And the value is our CSS value from 0 to 255. And then we will also use 3, which is R, G, and B, to send 3 post requests. So that is how I wired up my RGB LED. And we will also play a little bit with the proximity sensor. So here I have linked it with the VCC, or the voltage, and then the ground. And then the other 2 pins are connected to the digital. So RGB is using analog because it needs value from 0 to 255. And over here, I'm using the digital pins. All right, so let's see whether it works. So in order to talk to your Spark, obviously I've claimed it, I have set up with the Wi-Fi here. You need 2 things, because obviously you cannot talk to everything, right? Just like an API exchange, there is a device ID, and there is also an access token. All right, so let's add the Spark config. So there you see the little LED here. This is not a screenshot, this is right here. Okay, so what I'm going to do is I'm going to bring a color. So why don't I try this bright color, my front trends thing. And I'm going to point it right here. And let's see. Sending, sending, sending. Come on. Yes, the LED did turn. Can you see it? Okay, since I've already done this, I want one of you to come, but maybe somebody with a bright green or bright blue can come up and try as well. Bright green or bright blue, or any other bright color. All right, and if for the brave volunteer, I have another surprise for you as well. All right, so what color do you want to try? You will try your T-shirt. Okay, come. Let's try your T-shirt. right, and there you see the LED. Do you see the LED? There you see, it's blue in color. All right, thank you for volunteering, but I'm going to now, with your help, try the proximity sensor, shall we? So I'm going to connect to the proximity sensor here. And this is in line of sight. You can just put your hand there and see the bar moving. Maybe give it some time. Oh, there you go. Yeah. Yeah, so you can even go. This takes like about 200 in line of sight, by the way. And yeah. Yep. Yeah. All right, thank you so much. Thank you. I didn't want to do too fancy things. I really wanted you to go home thinking that this is easy enough, that the first step is cool, and I want to try it myself as well. So in this example, what I did is just two types. Maybe first I explain. So the camera here is getting the Get User Media API. You know, one of the cool things of speaking on the last day is that the speakers previously have already explained them. So go and watch Phil's talk on Get User Media API. And then I use something called Color Thief, which gets the dominant color of the entire picture, and then I saturate it. I maximize the saturation so that the LED can be seen. Maybe next time I should use Tim's Nerd Disco LED so that it's so bright and everybody can see it. All right, and that's what's happening in the client side. It's all client-side code. And then all I'm doing is sending a HTTP post request. And I'm doing it through Spark's default Tinker firmware, and I'm doing an analog write. Hey, write this value to this pin. That's it. So this is from the browser to over here. Next, we have the sensor, which is the proximity sensor that our kind volunteer did it for us. So in this case, what we are doing here is we are setting up a server-sent event. So once again, thank you, Cornell, for going to server-sent event. I don't have to spend much time on that. So server-sent event, every second it is basically emitting the centimeter distance. And over here, the hardware that I linked up is a proximity sensor. So let's go through the code. As you can see, here is just a post request. Of course, you can use jQuery post or Angular post or anything. I decided to use plain JavaScript. But more importantly, look at the URL here. Isn't it something similar to what we have already done when we interact with other APIs, let's say Facebook API, Google API, whatever. And over here, look at the params. This is the access token, and the params is pin and the value. All right, so what about from the sensor, which is proximity in this case, to the browser? This is the firmware code, and every second, I am publishing an event called distance. And over here in the JavaScript, with the help of server-sent event, it is picking up the same distant event. And of course, once you get these numerical values in the browser, you can do whatever you want. You can port it to the progress bar like what I did. Once again, all the code is fully available. You can check it out later. So explore today. There are more such libraries available for you to control hardware, the pins. For example, there's Cylon.js. There is also Johnny5. And both of these have very good documentation, good community, even offline events such as node bots and node boats and so on and so forth. So then there is also Tessel. So Tessel is slightly different in a sense that it comes with its own microcontroller board. And from Tessel version 2, you can actually write JavaScript, which runs on V8 inside the microcontroller. OK, great. So lastly, we have the third example, which is Bluetooth Low Energy. And I'm very, very excited about this. Let's talk a little bit about wireless protocols. All of us are very familiar with Wi-Fi and GSM, which are 3G and 4G. I'm very excited about two other protocols, Bluetooth Low Energy and Zigbee. What is the significance of this? Because they are low power, it can run in coin cell batteries, and you can just leave it out there, maybe at the top of the tree or in the top of the ceiling somewhere, and it can potentially run for years. Maybe every hour it will just send you some event telling you something about what you want to measure. All right, so let me show you one board. So this is a NRF 8001. So this is a BLE chip breakout board. I bought this from Adafruit. You can link this to other sensors. So this is a little difficult for beginners. But what I love is the next one that I'm going to show you. This is the TI sensor tag. Oops. All right, this is the TI sensor tag and how it looks like. Oh, the camera is distorted, right? Okay. So let me take out the red wrapper, the red rubber wrapper, and show you inside. This tiny little device actually has temperature, humidity, pressure, accelerometer, gyroscope, and it can even detect some clicks as well. This tiny little device, that's it. And it is using this BLE chip called CC2541. I've hyperlinked all of them, so feel free to browse it afterwards. And the cool thing is, like I said, it runs in this tiny little coin cell. Guess what? I didn't even change my coin cell. I bought this TI sensor tag almost 2 years ago. Of course, now and then I do some experiments, but this is the power of it. Are we ready for some demos? My third demo. All right, cool. So this is a Node library, a Node app that I wrote. So why don't we take a look at the package.json that I wrote here. So in package.json, async.js is, of course, to handle our callbacks and stuff. But take a look at this one. sensortag is a Node package module that is already available for you to interact with this little guy. And I also had a friend who coded sensortag shake so that I can take the shake device and do something cool. All right? So, are we ready? Shall I start? Yeah. OK, so here is the little device. It's near. OK, I should probably put this on. Otherwise, I cannot click the buttons. It's a little hard. So let me put this on. And firstly, I will, after I start the Node server, it will, OK, let me click the button. And it's connected. So let's see, starting accelerometer. It will give you the temperature, 23.3 degrees. Organizers, is that the correct temperature? OK, now you know it is 23.3 degrees. Humidity is 42%. Pressure is, and there you go. This is. So as compared to the first example, it was measuring angle. This is measuring angular velocity. Okay, so notice when I'm not moving, okay, the blue color is pretty significant, pretty stable. And as I'm moving fast, the numbers will also be bigger. But what can we do with this, you know? Well, there's Web Audio API. Why don't we try something? Shall I play it? You know, this audience from the past 2 days is like full of DJs and musicians. I don't even dare touch this one because I'm not a DJ. So I want a brave volunteer to come here. So I'll tell you what now we will try to do. This number, I'll port it to a music. And as you move your hand faster, the music will be faster. Of course, the frequencies and everything will go haywire, but who cares? We'll have fun. Is there another brave volunteer who will come up here and shake the TI sensor tag? Otherwise, I'll shake it. But anyway, come on, it's fun. Yes. So as she shakes, of course, watch the blue color. So I'm going to, all right, so she'll be the DJ, not me.
Wake the fuck up.
And you can slow it down. So it's going, and you can slow it down again.
Time is only presence, the only one true gift. How can it be yours without mine, and mine without yours? In this ever-moving infinite, beautiful, chaotic.
Thank you so much. Thank you. Thank you so much. The good news is, she asked me, can I take this home? The good news is, this is pretty affordable. So yes, you can play with my TI sensor tag as long as we are here. Great. So let me kill the node server, shall I? All right, cool. So let me go through the code a little bit. So on the client side, I was using Web Audio API. And on the server side, I was using Node sensor tag. And what is the hardware? I use the sensor tag. And of course, my laptop has to have a BLE hardware. If you don't have it, just buy the USB adapter for BLE. And that's all. And of course, I'm using WebSockets to do the exchange between the client and the server. So this is the brief, or rather the basic part of the TI sensor tag. As you can see, over here, I'm requiring it. And then with async.js, just so that the callbacks are handled properly. This is an example with the IR temperature. But the rest of the sensors are pretty easy. That's because the author has made it pretty easy for us to call them. And of course, in the client side, this is the Web Audio API. So the basic notion of mashup is this. You have some sensor numbers, and you basically bring it to the browser, and you port it to different things. So what about the browser and Bluetooth Low Energy? Keep in view this web community, Bluetooth community group. In a few years, we hope that there will be Bluetooth supported natively in the browser. So if you want, you can also get involved in this group. And as of today, take note of these two repositories. Sandeep Mistry is probably the JavaScript guy for Bluetooth Low Energy. He built the sensor tag. He also built something called Noble, which is sensor tag built upon. Also, take a look at Chris Williams' repositories. He has things like Node serial port as well as Voodoo Tiki Spark, which talks to Spark for faster performance. So yeah, start it. And if you're still confused about what I spoke about, I wrote all the details in an article just a few weeks ago, Electronics for JavaScript Developers Using Wi-Fi and BLE, and you will have some steps there as well. So what is the mashup all about? Like I said, you have various sensors, you have proximity, you have LED, you have accelerometer, and once you get these numerical values to the browser, you can get or do a lot of cool things with CSS animation or WebRTC, Web Audio API, Browser API, which are more and more becoming available. So this is the mashup that I was talking about. Now, today I've only touched sensors which can interact with the physical world. But imagine there are wearables, which I'm sure all of you are aware of, robots, and who knows, maybe one day we can even see browser data from the satellites. What does this mean? When we interact with the physical world as web developers, you know, when I first came into the web world, everything looked so pretty to me. There were the documentations were pretty, things were fast to do, were at least me coming from electrical engineering. So when we take this data and we kind of use it in a way where we can educate others to track our usage in the cities we live in, or maybe even learn from nature using sensors that we hook onto little birds or animals or plants, or maybe even discover something about the universe. So I would say, let's play with the real world. Thank you very much. Thanks.
Can you give us a rough idea on the prices of those devices?
Yep. I'm really, really sorry if I don't say it well enough, but this is about probably 20 to 30 US dollars. Arduino Yun, you can probably also get an inventor's kit about $50, $60, but really it's pretty cheap. I have some links there as well that you can click to places such as Make Magazine or Adafruit, SparkFun. You can click it. It's really under $50, $10, you will be able to get something. These LEDs and resistors are even cheaper. Wires are very cheap. Yeah.
So what would be the most everyday life application of, for example, this technology you have shown us? For example, did you use it to somehow make your everyday life easier in some funny way?
So right now, as with every technology cycle, for example, television or mobile phone, I think what we are seeing is the beginning of the technology cycle. And that's why it is not widespread in consumer devices. And that's why we engineers, designers, and developers have to come with it. But in terms of applications, people have been using it in their houses. For example, people have their own inbuilt security camera, or they have musical instruments, or they have like cat feeder, or they have like, I don't know, like Insta picture taker. So start building applications by yourself. So yes, I agree with you in terms of mass products. It will probably take about 5 years to 10 years, as with every technology cycle. But until then, us developers and engineers and designers will do something cool.